All right, Bismillahirrahmanirrahim. Uh, as I promised you that I will be assisting you for the Viva questions, and to all of you, as I've told you, just how to prepare well for the Viva is basically to look at the questions at the back of your workbook, practical workbook. You need to do those questions basically and write them and submitting the workbook. And number two, these are some extra questions that possibly uh, will help you in preparing for the overall Viva, okay, of the machine design. So what are the different types of loads that acts on the machine components, okay? All the machine components when you talk about whether it's basically a bearing or a shaft, okay, so these are the different types of loads can act on the machine components are steady loads, variable loads, shock loads, impact loads, okay. These are the main things. What are the various phases of the design process? Okay, these are the main phases of the design process are recognition of needs, definition of problems, synthesis, analysis and optimization, evaluation, and final presentation to the customer about the design process. So these are the design process. Basically, whenever you're designing any machine component, basically, or any system or assembly of any related to machine design, okay, these are the fundamental design process steps. What are the type of the variable stresses that acts? It could be if basically the component is basically going under cyclic loading, so it could be cyclic stresses, fluctuating stresses, and repeated stresses. So these are basically types of variable stresses are cyclic stresses, fluctuating stresses, and repeated stresses, okay. They basically come when any object is under the state of what is called as fatigue loading, okay. What are the type of fractures? You can have a ductile fracture, and you can have, if your material is basically ductile, okay, like MS or basically aluminium, it will have ductile fracture. And if a material is brittle, for example of materials that you could ask is cast iron is brittle in nature. So basically these are type of fracture, ductile or brittle fracture. Stress concentration is the increase in local stresses at any points of rapid change in the cross section or discontinuities, okay. For example, if you look at it, we have if you look at it, if we have an object like this, okay. So this space here, you see, this is 90 degrees, this is 90 degrees, okay. And so we always want this shape to be something filleted like this, okay, because it is to be filleted like this, not sharp. So we do it in order to reduce the stress concentration, okay. And other factors that basically include is basically you have a small hole, okay. If you have a small hole, so the near to this hole, near to this vicinity, the stress concentration will be very high, okay. Remember this thing. So what are the factors to be considered in the selection of materials for machine elements? Are the required material properties. For the selection of the machine element, you need material properties, okay. So this is very important. You need manufacturing ease. This is also very important. Ease of manufacturing, that the manufacturing process selected is easy. It does not depend upon several different manufacturing processes for the assembly. It should be as easy as possible to manufacture in the minimum steps. Material availability is very important. If the material is not available, there won't be any manufacturing for casting of any other machining process, okay. And the cost should be reasonable. It should not be too high, otherwise their profit will basically decrease, okay. So then you have if you look at it, bending equation. Bending equation is basically whenever the beam is under load, okay, whenever you have got this type of a beam, whenever you have got this type of beam, you have Okay, this is your beam, and if you apply a load on that beam, okay, so it will undergo some sort of a bending. So for whenever this happens, okay, the beam will undergo what is termed as the bending. Okay, so the loading basically can be of anything. If you look at it, the loading on that beam could be anything. It can be a point load. For example, this is what it is. You can have a one load here, you can have another load here, okay, and you can have a UDL also. So remember, any type of load, you can say omega, this is P1, this is P2. Okay, so this beam will basically go what is called as it will undergo some sort of a bending with some deflection. Okay, it will have some sort of a deflection. So during this, it will undergo, as it will go under deflection, it will also have some bending stresses. To calculate those bending stresses, we basically use this equation. We basically use which equation? This equation. M upon I equals to E upon R equals to Fs upon Y. Okay, remember, where Fs is the bending stress. Okay, Y is the distance from the neutral axis. Okay, it is basically this distance from the neutral axis, from this point to this point. It is this point. Okay, neutral axis. Then the radius of, again, R is the radius of, basically R is termed as the radius of curvature. This R is basically the radius of curvature. I is the moment of inertia. This F is the bending stress. Okay, and Y is again telling you it's basically the distance from the linear distances from the neutral axis. Okay, so fatigue, when a material is subjected to repeated stresses, it fails at stresses below the yield point stress. Such type of failure is called as the fatigue failure. Okay, basically the stresses are cyclic in stresses or repeated stresses. Okay, it can be any basically component or system. The clutch and brake assembly has undergo repeated stresses. Okay, basically the shafts, when it is rotating, it undergo repeated stresses. Okay, cyclic stresses. So how, this is the definition of fatigue. How is the bolt designed? The bolt is designed by a letter which is called as by letter M. Okay, this letter M, followed by the nominal diameter and pitch in millimeters. Okay, for example, you can say, if I say M12 into 2, it means the diameter of the bolt is 12 and this is the pitch is 2 millimeters. Okay, so what is pitch? Pitch is defined as a distance from a point of one thread to the corresponding on the adjacent threads is the same in the same axis plane. Pitch. Okay, lead, again for the screw, is the distance, is defined as the distance with the screw thread advances axially in one rotation of the nut, that is the lead. Okay, so flywheel, if you look at it, what is a flywheel? Flywheel is a machine element used to minimize the fluctuation of speed in the engine. Okay, basically it basically stores the energy, and basically it is being used to minimize the fluctuation of the speed in the engine. What is bearing? Okay, so bearing is a stationary machine element which supports a rotating shaft or axle. Okay, and confines its motion. Okay, is termed as a bearing. On the motor with low starting torque, the type of clutch to be used is, okay, you've got many options to select for a basically low starting torque, basically the motor. The type of clutch, what type of clutch to be used, you have multiple options: the multiple plate clutch, the cone clutch, centrifugal clutch, single plate clutch with both sides effective. Okay, so as you've studied different types of clutches, for this the answer will be the centrifugal clutch will be the most optimum to be used. Then there are fundamental definitions being explained here. Is screw is specified by, in order to specify a screw, you need major diameter, minor diameter, pitch diameter, and mean diameter. In order to specify a screw, the major diameter is the main parameter. The rest are again not that important. The designation M36 screw just explained. It means M stands for metric, 36 is basically the diameter, the outside diameter, and 2 stands for the pitch. It has to be in millimeters. 36 also has to be in millimeters. Okay, so if you look at it, A is the answer. Metric finds the outside diameter and 2 millimeter is the pitch. Then here in the assembly of pulley, key and shafts, pulley is made the weakest, key is made the weakest, or key is the strongest. All the three are designed for equal strengths. Okay, for them we basically make the key is made the weakest, so it is cheap and easy to replace in case of a failure. Okay, so the key is usually made up of the mild steel material with the lower strength, so that it can be replaced in case of a failure. Name the components. Now this is the component I will give you. You have to name what type of a component it is over here, but just by seeing the picture. Okay. Then you have what is called another components. These are the ball bearings. One of them. What is the name of this component? Okay. Okay. This is a general bearing. Okay. What is this? This is the housing. Okay. And this is the bearing. And from in this we can place a shaft. Different types of bearings: roller bearings, ball bearings, plain bearings, okay, flexure bearings, needle bearings. Okay, these are all the different types of bearings that we have. Okay, these are basically the tapered, the tapered bearings. Okay, just explained over here is basically these are the tapered bearings. Then this chart explains a very important chart here. It is the bearing types compared. Okay, what are they have shown you ball bearings. Okay, cylindrical bearing, its advantages of ball bearing: low cost, compact, most widely used, along with disadvantages. For cylindrical ball bearings, we have given you advantages, disadvantages, so you can study this as further for your knowledge. Now this is component is given to you. You have to name the component. Okay, what is the possible name of this component? Then there is basically a section drawing is being shown to you for a shaft design with various components. There is basically if you look at it, they have shown you a frame, a shaft is there, then there is a hubs, and then there is basically pulleys with basically various keys, the Woodruff keys, the profiled keys, and here a gear is being placed. What are these components for a section drawing? Showing you the various the shaft with its various components to form an assembly. Then what is the name of this component? Okay, you just have to tell what is the name of this component. You must be able to tell it. Then these are the very simple, basically from the machine design point of view, simple questions. What is stress strain curve? You must tell. Draw the stress strain curve for mild steel and aluminium. Okay, you have to draw it for the mild steel and aluminium. The stress strain curves there basically give very simple definitions like stress strain. E stands for modulus of elasticity. G is the Poisson's ratio. Okay, if you look at it. Okay, so E and G is the section shear modulus. P is the Poisson ratio, torsion equation. Okay, strain energy. Discuss the gear drive system in detail. This is again your full practical. You have to study it to discuss it. Various things could be asked. Discuss bearing mountings and dismounting techniques. Again, your experiment with we have done it in very details, and lot of questions could arise, can come. If you read it, you will see how bearing faults affects the assemblies. Again, your practical, very important practical. Then puller, what is a puller and what is its use, and you need to sketch its drawing, simple drawing. Then some other components over here. I have questions that will help you understanding this the subject, and during the lab we have discussed it also. The plastic deformation which persists after removal of applied load, what is it? Again 23, 24, strain energy stored per unit volume is what it is, the resilience. Okay, you can draw. If I say you draw the diagram of resilience, you have to show. Okay, draw the load per unit deflection. What is number 5? Load per unit deflection. It will be the stiffness of the material. Okay, because you know F is equals to Kx. So K, you know it very well. That here it is. F is equals to Kx. Okay. So what is K? K is nothing but F upon X. Okay, so it is basically load. F is equals to Kx, X is the deflection. So load per unit deflection, load per unit deflection. This is load and this is your deflection, will give you K of the material, which is the stiffness. Okay, so all these 26, 27, 28, 29, 30, 31, if you look at it, these I have also given you the answers, so that you will be able to try to basically understand these problems, so that your concept is more clearer and your knowledge is also increased. Okay, so I hope again you have to basically study these problems along with the problems of the work, the questions asked at the end of the practical workbook. So this and plus this, and again I think it will be quite substantial for your for all of your viva preparation. And with this, thank you.